Hello, welcome to BC Calculus, hosted by your dear friend, Mr. Henry Lombino. Alright, I'm not doing that voice for the whole thing. Alright, so we have this wonderful example of a integral right here that we need to use integration by parts to solve. So, here's how we're going to do this. So right now it's a little bit confusing because we've got the things, one on the bottom, one on the top. So we're going to change that up. So we're going to put them all into one nice good old line so we can see them for what they truly are. No, we're just going to see them nicer. Alright, so what this turns into, oh god. So this is going to do is t plus 7 times 5 minus t to the negative 1/2, so to the dt. Remember that dt. And so now that it's all nice on one line, you can see it easily, and now we can choose our two parts, our u and our v. So I'm going to choose this one right here, because if I add or subtract 1 or 2 halves to this, it's never going to equal 0, meaning that this will never negate out to, this will never go to just 1, and meaning I can never really eliminate a variable here, and these will never cancel for obvious reasons. So I should focus on getting this down. So what I'm going to do is I'm going to put this at u. So u equals t plus 7. All right, that's simple enough. Let's put parentheses around that just so I can think about it more clearly. And meaning that, and the derivative of that is just 1, which is so nice because I really like 1s because they're just so nice and so simple and so, I'm gonna write a love story to 1s, a love poem to 1s in calculus. All right, and now we have our v and our v derivative. So our v derivative is going to be 5 minus t to the negative 1/2. And now to get v, we're going to find the integral, or no, the antiderivative of that. Now there's going to be there's a lot of messy old negatives in this bit, so we're going to have to be careful. So when I go this way, so I know it's going to be 1/2 because this is negative 1/2, and I add 1 to that, so that gets me 1/2. And I know the general is going to be that, but now I need to decide if there's a negative or not. Now, so this is going to go down. So I actually need to cancel out this. So 1, because this is going to multiply by 1/2, won't go anywhere, but I need to cancel that out. It's going to be 2. And then let's think about this. And then this negative is going to go out. So I need to cancel that. This negative t is going to go out here. So I need to cancel that, make it negative 2. So now we have, yeah, so that should work. So those are our u's and v's. So now we need to plug them in to our integration by parts formula, which is this. U from Mr. Seamon, of course, I already know that, but it's probably a good idea for me to write it out. Show all my work. You know what I'm talking about. And then dx. Don't want to forget that dx. Very important, that dx. Oh, and these are also dx. Oh, how could I forget that? How could I? Silly Henry. Dishonor on my family. That was a Mulan reference. I hope you like Mulan. Mr. Seamon, you should watch Mulan. It's a great movie if you haven't seen it already. Alright, so now back to math. So here we got so now we have this. Now we just plug it in. So we have of t plus 7 of 5 minus t negative 1/2 dt equals, we have t plus 7 negative 2 t to the 1/2. So we got that. That's that bit right there. Minus the integral of 1 to the times -2 times 5 minus t to the 1/2. Now, alright, so that's that. So now we're going to focus on this part because this is what we're trying to solve for. So now, there's a lot of things I can do with this, but the biggest thing I can do is, number one, I ignore this one. Ignore that one because it doesn't mean anything. Because, as for now. So I'm going to ignore that, and then I realize that because that is 1, I can now just integrate all this bit as I just normally would, just as a standard integral. So that's really nice. So yeah, so I'm going to do that right now as soon as I erase this arrow. God. Alright, there we go. Alright, so let's do that. So let's do, I'm also going to put up this -2 out here, and that'll come in the next step. So 5 minus t yeah, 5 minus t to the 1/2. Sorry, I thought I had done something wrong, but I hadn't. I got this. I'm gonna bring this -2 out here, so it becomes -2, the integral of 5 minus t to the 1/2, and I can solve for that. So let's do this. So let's do -2 t plus 7, 5 minus t to 1/2 minus, let's just do positive 2, because those negatives cancel out, and then we're going to integrate this. So this is all, and so by integration, so going to get, so this is going to go to 3. So we have our standard. So this is going to go to, so this shebang is going to go to 3/2 because you add it, well, add it by 1. No, not add it by 1. Add 1 to it. And then we have to cancel this negative, which is going to pop out. So we have to make this all negative. And then we have to cancel this, which is all going to multiply down. So we have to do 2 over 3. Let's put that negative right there. So we have that. So yeah, so that's that. And then we can do some more so that's basically it. We're gonna do some more. I'm just gonna do a little more bringing out because I can. So so let's do this. So let's bring out the -2 because I feel like it. So -2, whoops, -2 t plus 7 times 5 minus t to the 1/2, and this is going to go, so this negative is going to go to this 2, so it becomes -2, so it's still positive. So plus, but I'm only taking 1 2 out, so this is still 2 to the 3rd 5 minus t to 3/2 on parentheses. And there's our answer. And it's really messy, but it doesn't have the integral sign, which is nice, which means it's not an integral. It's just a polynomial. And that's really nice and really, really good. And that's the end of the problem. Hope you enjoyed that, Mr. Seamon. Remember to watch Mulan. And yeah, have a good night.